So in this video, we're going to continue to talk about the sampling distribution for a sample mean. And if you remember, we began talking about some of these conditions that we definitely need always, that we had a simple random sample, that we collected the data well, is really it. The mean of our sampling distribution is going to be the population mean. And the standard deviation we talked about, that the original standard deviation, it's related to the deviation of the sample mean, but as the sample gets larger, the sample mean should get more exact, so we divide by, in this case, the square root of n. And you can look at why it's the square root of n in the previous video. You don't need to know it, but for any AP exam or anything, but it's kind of a nice explanation. And finally, we do need this condition still, the 10% condition, that the sample size is less than or equal to 1/10 the population size. The same reason we needed it with sample proportions. We have to ensure that the sample is not getting so large that we don't have variability from the population mean anymore. Okay, let's work an example. The heights of redwood trees that are over 150 years old are approximately normally distributed with a mean of 185.2 and a standard deviation of 7.1. If we go to Yosemite National Park and measure one tree, what's the probability that tree is over 200 feet tall? Okay, so it's not really a sample mean problem. It's kind of our old, normal curve. We say, well, there's a normal curve, and we got 185.2. Got 7.1, and we want to know the probability of 200. Okay, so let's calculate that. Okay, so I've used the calculator. You can see the probability is 0.019. Now, if we sample 10 trees, what's the probability the mean of our sample is over 200 feet? So now, we're talking about a sample mean. Now we expect the sample mean to be centered at, our distribution of sample means to be centered at 152. But remember, we expect that sample mean distribution to have a smaller deviation. So it's 7.1 divided by the square root of 10. And we're still doing 200. Okay. Now, I'm going to calculate this probability, and then I want to talk about the relationship that exists here between the two answers. Okay, so you can see it is a much smaller probability. And here's why that should make sense, other than just the calculation piece of it. In the first example, we said this is the distribution, centered around 185.2. This is the standard deviation. What's the probability one tree is over 200 feet? Here we're saying we collected 10 trees. What's the probability they have an average, a sample mean, an X bar over 200, if this is the real mean? Once we start sampling and taking the average, our sample mean should get closer and closer to that 185.2. And in fact, it hasn't. It stayed over 200. That shouldn't have happened. That's why this is so much more improbable than the first example. Because in the first example, yes, there's a distribution. One tree, fine. Makes sense that one tree is going to be over 200. But 10 trees to have an average over 200, that is very improbable, given that this is the population mean. If we take a simple random sample of 30 trees, what's the probability the sample's less than 175? So again, normal settings are 185.2 and 7.1 over the square root of 30 and 175. So you can see the calculations here. Again, very improbable. The sample means, once we have 30 trees, the mean of that sample of 30 should not be that far away from the population mean, according to this probability. Finally, if you took a simple random sample of 25 trees, what's the probability it's between 180 and 190? 180 190. You can see that is a very high probability, and that makes sense. Sample means should be clustered close to the population mean, especially with a sample the size of 25. So the big ideas here to get out of this is that as we begin to move away from individual observations towards the averages of samples or the results of proportions with samples, we have to adjust our variability because while single observations can be far away from the mean, once we have a sample and we calculate the mean of the sample, that really should be getting closer and closer to the population mean.